I can rotate a figure and determine its coordinates. And your IXL skills that you should be able to work on are L7 and L8. They will not take a long time, so please, again, do not wait until Friday to do them. They should be all updated by the time I see you in class this week. All right, so let's go flippers. All right, we're going to talk about rotations. Rotations are transformations that turn a figure about a fixed point. Okay, so if I were to draw an R and then I were to turn it, first way that I want to turn it is counterclockwise. And counterclockwise would be the opposite way the clock goes. So we'll go toward the 11, the 10, the 9. So let's do it. Here's the same R turn counterclockwise 90 degrees. Now, if I were to turn this counterclockwise 90 degrees, aka 207 degrees counterclockwise, it would also now look like this. So it's really important to understand that this 90-degree clockwise rotation is the same as a 270-degree counterclockwise rotation. And in most texts or most questions, they often say, you please rotate about this point. And the rotation is usually focused on, again, counterclockwise. So that's what you need to be thinking now, going this way. So let's try it. All right, so I've grabbed triangle ABC. These are the vertices A, B, and C. A, B, and C in blue. Okay? So now I'm going to do a rotation of that same triangle 90 degrees. And again, remember, it's counterclockwise, so we're going this way. Okay? So the first point, A, actually goes right onto itself. A prime is simply 0, 0. Nothing changes. But for B, which was at 4, 0, it actually moves to 0, 4. So there it is up here. And C actually moves to negative 2, 0. And if I connect these points, you can clearly see that the triangle has been rotated 90 degrees counterclockwise. So if I want to try and see what actually changed when I did that with the actual coordinates, I can say this happened. The original point, x comma y, actually changed to negative y comma x. So they kind of flopped. They flip-flopped. So now I've clearly graphed a rotation of 180 degrees. And here A, again, is still in the same spot. But B now has gone to negative 4, 0. And C to 0, negative 2. And remember, this was from the original vertices, the original points, which were here. This is a rotation of 180 degrees. So if we look at the coordinates again, under a rotation of 180 degrees, we're going to have our x coordinate actually just become negative. And our y coordinate is going to do the same thing. So become negative. Now again, if it was positive, it would become negative. If it was negative, it would become opposite. So it's going to flip. It's going to switch. Okay, so the last rotation is a 270 degree rotation where A now again is in the same spot, didn't move. B, however, now is going from its original location here of 4, 0 all the way over here to 0, negative 4. And C has gone from its original location here at 0, 2 down to 2, 0. Okay, so here's our new figure. And again, this is a 270 degree rotation. Here, if we analyze what happens with a 270 degree rotation, we will see that the x and y actually switch spaces and the x becomes flipped, no matter what it is. It is important to note that you will sometimes see composition transformations, or we'll have some combinations where we have maybe a reflection and a rotation. And you actually see that in a game that you're going to play this week that I actually previewed in one of the classes, TransStar. So it's really cool, and you actually have to do this. And it's going to be one of your IXL skills this week that I'm going to let you actually swap out to do TransStar, as long as you can get to level 3 and complete it. All right. Okay. Finally, example number 1. If the letter P is rotated 180 degrees, which is the resulting figure? If you were thinking option 1, you're absolutely correct. Let's classify the other ones while we're at it. Answer number 2 represents a 90 degree rotation. Answer number 3 represents a 270 degree rotation or a 90-degree clockwise rotation. Yes, those are equivalent. That does say clockwise. And the last one is a reflection, so that one does not actually count. Number 2. What are the coordinates of A prime, the image of A, negative 3, 4, after rotation of 180 degrees about the origin? So here, if we look at, this is where A would actually be, and we're trying to figure out where A prime would be. All we have to do is think about, if it's a 180-degree rotation, we're actually making both of these coordinates negative. So it's actually going to move to not negative 3, but 3, and not 4, but negative 4. So that's where it should be. Our answer is going to be 4. Number 3. Are these figures below congruent? Well, if we look at them very carefully, it looks like they're the same, but it's definitely not going to be the result of just a rotation. This is an example of a translation and a rotation. So yes, they are congruent, but you need multiple things to happen. Translation and rotation. And on to our secret question. Here it is. It says, the accompanying diagram shows the starting position of a spinner on a board game. How does the spinner appear after a 270-degree counterclockwise rotation about point P? Is it 1, 2, 3, or 4? Remember, 15, 15. Remember to work on your IXL skills, L7, L8. Have a great night.